So it's my honor to be with you today and to convene this panel at our annual conference that deals with one of the most pressing issues facing humanity today, which is consistently ranked among the issues of highest concern and which generates a sense of urgency for a large segment of global population, that is climate change. But before starting, I have to apologize since one of our panelists is not with us today. We were really looking forward to having Professor Catriona McKinnon of Exeter University on the panel. She was unable to join us as her flight yesterday was canceled. And compounding this loss, that leaves us with an all-male panel, for which I have to apologize. Sorry about that. It was unintentional, and the responsibility lies with KLM Airlines. I will, however, use this opportunity to speak a little bit longer than what I intended to before passing it on to the panelists. So we, as a society, have solved some of the world's most pressing environmental problems. We've solved acid rain, we've solved the hole in the ozone layer, polluted rivers and air. We have brought species back from the brink of extinction. And democratic participatory decision-making and governance and open societies have been critical factors in these successes. In international law and policy, these advances take the form of the concept of sustainable development and especially Principle 10 of the Rio Declaration. This morning at the opening, the rector spoke about crony capitalism. Our keynote speaker also spoke about how law protects capital against the world. But these are two sides of the same coin, in which the relationships are among humans, the haves and the have-nots. But nature doesn't respect capital, and law alone can't protect anyone, even the richest and the most powerful, against it. So environmental issues have been politically transformative. The Chernobyl disaster shook the confidence of the public in the ability of the Soviet system to manage environmental risk and human safety and security, and played an outsized role in the political changes that led to the era of what we called in the 1990s transition in the pan-European politics. That was about democratic governance over a high-risk nuclear power industry. And those who played with the Chernobyl power plant and caused the accident, if you've watched the documentaries about it and the stories, they were the equivalent of the tech bros of scientific socialism. One of the questioners this morning spoke about security. Ecological urgency is on the boundary between two coexisting systems of law and economics. It's a driver of the acceptance of concentrated hierarchical power in a small number of individuals. So when we look at climate change, it's a sticky problem, and while there has been incremental progress in several areas, including energy efficiency and overall reduction of greenhouse gas emissions, these developments, even though they are currently under attack as well, have been far from enough to offer hope that the global community will avoid the disastrous impacts that are projected to occur. And climate change is only one leg of the triple planetary crisis we are facing, along with biodiversity loss and pollution. So if it's an emergency that we're in, where might we cut corners on democratic accountability? Should we do that, and what do we do to solve the problem? Wouldn't it be great if there were technological fixes that could be deployed to solve the triple planetary crisis? Today, the world is once again embracing strong leaders who may not have the answers, but who act decisively. They are allied with and make use of the possibilities of big money in the hands of powerful people, giving us hope that they might buy us out of our big problems. That could be wonderful, or it could be cataclysmic. In Ottawa last year, in the negotiations of a new treaty on plastics pollution, there appeared a panel of representatives of large funds who represented that they have $17 trillion at their disposal to deploy to eliminate plastic pollution. But the negotiations for the treaty are deadlocked. Who gets to decide what the money will be used for? And the EU has announced very optimistically that it will put 2 billion euros into what are called nature-based solutions. After more than 5 years of discussions, the international community still has not defined nature-based solutions. Meanwhile, a researcher from Friends of the Earth has studied a wide range of NBS-labeled projects and found that they actually produced net harm to the environment. Why is that? Because researchers and authorities prioritized pet projects with speculative and unpredictable results. So also this morning we heard several people use the word tension. Among the tensions that we talked about, or that we can talk about, that we will talk about today, is the tension between whether it's virtuous to be hyper-wealthy and whether the hyper-wealthy can justify their excessive wealth through solving problems, through becoming heroes. In periods of crisis, such as we now face, the hyper-rich and hyper-powerful may attempt to use their wealth and power to solve existential problems, but these attempts, no matter how well-intentioned, raise issues in regard to unintended consequences, unacceptable risks, and inequitable impacts. Elevating the hyper-rich to hero status also insulates them from democratic accountability. We will hear more from our panel about the attitudes of the current generation to this dynamic. Yet my own informal poll involving the UN Children and Youth Major Groups from the High-Level Political Forum and in the United Nations Environment Program contexts shows that while the younger generation is divided, a substantial part of the youth today is at least hopeful, if not actually optimistic, about things like geoengineering to solve these issues, to solve these problems. But what, in the meantime, has happened to faith in the role of the public through democratic decision-making and governance in this area? Are we ready to abdicate and to hand over everything to the rich and powerful? Should we trust the richest people in the world to use their immense wealth to save the planet, particularly when some ultra-rich are betting on things like collapse, like colonizing Mars, looking into post- or transhumanism, or merging with artificial intelligence? It's very common in the environmental field to talk about the free rider, such as the polluting capitalist who hopes that the public will look the other way while he profits from imposing the costs of doing a dirty business on the environment and the community. With supposedly well-meaning, hyper-rich, so-called philanthropists, we have a slightly different phenomenon. This is the free driver, the one whose wealth and power feel justified to drive the process of transforming our way of life without the typical moral, ethical, and governance constraints, and therefore imposes costs in a haphazard and unpredictable way on society as a whole, leaving us to pick up the pieces. Or will they actually succeed? That's what we're going to be discussing today, looking at the example of solar radiation modification. And why do we focus on SRM, as it's called? Because SRM is actually being done today. We'll hear some examples of that. We're going to discuss concepts such as lock-in effects, termination shock, and overshoot pathways, while focusing on our key questions, which are, can the hyper-rich save the climate? And should they try? Should we trust them to do that? I'm joined by our excellent panelists who are at the leading edge of these critical issues. They are among the world leaders in scholarship and policy development related to climate change and geoengineering. To my immediate right, Janos Pasztor is now retired after close to 5 decades of work on sustainable development, and in particular on climate change. Most recently, he was the executive director of the Carnegie Climate Governance Initiative, C2G. Before that, he was UN Assistant Secretary General for Climate Change and senior advisor to the UN Secretary General Ban Ki-moon. To his right, Benjamin Sovacool is professor of energy policy at Sussex University, professor of earth and environment at Boston University, and university distinguished professor at Aarhus University. He also has a CEU connection, having been an Erasmus Mundus scholar with us in 2012. And once again, we're sorry that we don't have with us Professor Catriona McKinnon from the University of Exeter. We'll start with brief presentations from the panelists, followed by a short dialogue, and then we will open up the floor to questions from the audience. So we'll start with you, Janos. Please, you have the floor. Thank you for your attention.
Thank you, and thank you for inviting me to this event. Back to CEU after a very long time. I spoke here many, many years ago, and it's always a pleasure to be back in the city where I was born a few years ago. Okay, so I've been asked to do two things today. First, there is these new technologies, new techniques called solar radiation modification or geoengineering, and I've been asked to give a 2-minute backgrounder so we all know what it is. So I'll do that first, and then I will switch to my actual presentation talking about the topic of let's see if this works. Yes, it does. So what is solar radiation modification? And basically the situation is quite simple. The sun heats us, sun rays come to hit the earth, and some of it gets reflected back into space. And there is a balance because there's gases in the atmosphere, so not all of it is reflected back, and there is a balance. And so the Earth's temperature is relatively balanced. The problem is that we've been burning fossil fuels, and we've been putting the so-called greenhouse gases in the atmosphere, which actually interfere with this balance and increase the amount of heat that is trapped in the Earth, and therefore it's getting warmer, including today in Budapest. It's pretty warm today. And so that's the issue, but some people some scientists have figured out that maybe we can do something about this. We can maybe put some material, some particles into the atmosphere, the stratosphere, so that already some of the sunlight coming in gets reflected back into space and thereby cool the planet. So that doesn't solve the climate crisis at all, because the only thing that solves the climate crisis is to reduce and eliminate our CO2 emissions, but at least it allows the world to reduce the impacts of the heating while we decarbonize. Now, there are a number of different techniques to do solar radiation modification. The simplest is what is traditionally done at the ground level, painting roofs white. The houses in the Mediterranean tend to be white for that reason. That's the simplest way to do it. But there are also more complicated ones, and at the other end, the most controversial one is called stratospheric aerosol injection, where we would take aeroplanes and spray material into the stratosphere that would stay there for a while and reflect sunlight back into space and cool it. In between, there are others like the marine cloud brightening, where it's basically ships going and spraying essentially saltwater spray into the clouds, and thereby changing the quality of those clouds, and they can reflect some sunlight. As we know, if you're under the cloud, it's cooler. And for example, in Australia, they've been working on this, experimenting with this to try to save the Great Barrier Reef, which is a very big area, but is having a real problem with the warming. So that's the technology. The technology is quite simple. The science is very simple. The problem with these is the governance questions. Who is going to decide to do it? What if something goes wrong? What if I don't want it? What if somebody else wants it? There are many, many questions. And after spending some years working on this, I think I can say fairly easily that the science, the technology issues can be solved very easily. The governance questions are much, much more difficult. And that is why the topic is very controversial. But nevertheless, we are in a situation where almost whatever we do, it's going to get hotter. And the question will arise whether or not societies are prepared to take and look at these technologies. So I will leave it at that. If there are any technical questions in the discussion, we can look at that. But now I'd like to go to my actual presentation, if I may. I think I'd like to start with the fact that our planet is in trouble, actually big trouble, because it's getting warmer and warmer. And in fact, it is the average global temperatures are warmer now than in the last 10,000 years. If you look at this graph, this is just the last 2,000, but you could extend it to 10,000 years, and you will get pretty much the same picture. The average temperature, there are some peak temperatures always a bit higher than lower, but the average global temperature has not gone more than plus or minus half a degree centigrade for the last 10,000 years, except the last few years. And let's not forget that it is precisely during this period that civilization developed and managed to grow and thrive. That is the so-called Holocene. And we have changed that just in the last few decades, suddenly with the emissions growing as they are. What the impacts of all that is and will be, some of it we know, some of it we don't know. But it is definitely a radical change. And that is something we shouldn't forget as we go into further discussions. Now, we are now officially 1.3 degrees above historical average. Is counted as a 20-year average. So even though last year was 1.5 and this year is likely to be the same, if not warmer, they count it over 20 years. So that's not very good, particularly because the aim of the Paris Agreement is to keep the temperatures definitely below 2 degrees, if possible, below 1.5. And according to the most reasonable estimates right now, it looks like that the temperature is going to reach something like 2.6 to 3.1 degrees by the end of the century. And the range is there because many countries are saying we can definitely do a certain amount, and if we do all that, in terms of emission reductions, then we'll reach the 3.1 degrees. But if we get additional resources, the so-called climate finance, then we can do more. And then the temperature, the average temperature will only reach 2.6 above historical average. I say only, but that only is still way too high, because already today, the impact of the 1.3 average is already significant. In fact, not only significant, but in many places catastrophic. We have floods, forest fires, we have excess heat in places where it's simply impossible for people to live. In Iraq and some of the in that area, temperatures are now routinely going into the high 40s and low 50s. It's impossible to live in such situations. You can look at the 2024 report of the World Meteorological Organization, and there is a whole list of all the impacts that are taking place. The problem is that it's going to get worse because the temperatures, the emissions are still increasing and the temperatures are increasing. And with some countries, and I will mention it, some of the big countries like the United States, what's happening there in terms of going backwards and reducing some of the good things that were taking place in terms of climate action will make this even worse. So that's the reality that we live in, and we have to realize that a substantial temperature increase is baked in already. Almost doesn't matter what we do in terms of our emission reductions. For the next few decades, the temperature is going to rise and the impacts are going to rise. Stephen, you talked about the triple planetary crisis, absolutely true, but in fact it's even more than triple. Many people call it the polycrisis because there are many other issues that are also there and they are interacting with each other. But anyway, let's just try to look at the climate situation. So obviously the first thing to do is to reduce our emissions as the highest priority. Not only CO2, carbon dioxide, but also methane, which is quite important. The challenge that we face is that we have addressed only the low-hanging fruit. It's easy to make photovoltaics and easy to make electric cars, very important, but much more difficult to have electric planes, different kind of steel making, etc., etc. So there are lots and lots of challenges that we have to do that are still looking ahead. But we also have to think that the concentration of greenhouse gases is already too high in the atmosphere. You can do a sort of a Gedanken experiment that if you remove all carbon from the atmosphere, if you stop all emissions today, even then, the temperature, there's so much carbon in the atmosphere that the momentum of the system is such that the temperatures will still rise a little bit, and then they will stay like that for hundreds of years to come, hundreds of years to come. So there's already too much carbon, and that carbon has to be removed. But that is taking time. We also have to adapt to the changes to the extent that we can, but we have to recognize that it costs money to adapt to climate change, and in many situations there are cultural, religious, geographic limitations to what one can do in terms of adaptation. And then there comes the situation that scientists have said, well, why don't we start thinking about cooling the planet, or cooling at least part of the planet? And that's the big question, whether the world is ready to start considering that option. It's controversial. We don't know enough about the science and technology that we can either accept or reject this proposition, but it looks like that we may need it. And if we may need it, then we have a moral imperative to actually look into it, do the necessary research to understand it better, so that one day we have an evidence-based situation where we can decide whether or not we want to pursue. So it's in this context that we're looking at the hyper-rich, and I'd like to switch to that part of my presentation now, because all the other actions that the world has been doing is not enough, it's too slow. So the question arises, can the hyper-rich fix this problem? And I have an answer, but I leave it to the end. Okay, so first let's look at what do the hyper-rich do today. And I think as a first point, I think it's fair to say that all the hyper-rich have their very different lifestyles than we all do in this room. They have their private planes, they have many houses, they buy lots of things, and so clearly their consumption is much higher than anybody else. Their per capita consumption is much higher, so you could say that's terrible. And it is terrible, but frankly, given the number of people concerned, if we stopped all that, we would still have a climate crisis in front of us. Let's be realistic. So yes, it's a problem that they do all that consumption and emissions, but not doing that will not save us. Now, they also have influence, all of them, one way or another. The rich they have many followers on X, on TV shows, on TikTok, and so on. And that can be a problem, but it can also be good if they use it for the right purpose. So let's just look at a few hyper-rich. And let's start with the person who helped to fund all this, George Soros. You know, he's put his money to lots of good things when it comes to climate. So in that sense, that's a good thing. And then there are others. I ran an initiative called the Carnegie Climate Governance Initiative for 7 years. It was funded by the V.K. Rasmussen Foundation. It's a family foundation from Denmark. They also decided to do something useful with their money. And then there are some good ones that are well known, such as Bill Gates, who has given enormous amounts of money for, mostly for health, but also quite a lot for climate. So those are fantastic. They're not solving the climate crisis, but they're definitely contributing to it. But then there are others who have done both good and bad things. If you look at somebody like Elon Musk, I think what he's done with the electric car situation, fantastic. He's really pushed the envelope with that. But then all this space stuff and going to Mars and things like that, I'm not sure how much helpful that is for the climate crisis. But what is even worse is when people like him get involved in politics and then they're pushing for the wrong solutions when it comes to the climate. And if you look at, in the United States, the cabinet of President Trump, it's worth, somewhere between $50 to $20 billion. The totality, so they're quite rich people, and look at what they're doing to the climate. It's just amazing. It's not only that they have stopped doing some of the good things that were in place, but they're actually removing those things and removing policies and measures so that the US is actually going backwards when it comes to the climate situation. And that means inevitably that the US emissions will rise, and so will the global emissions as a result. So this is what the hyper-rich do today. Now, what else can the hyper-rich do or may do in the future? Well, first thing to say, I think it's fair to say that they will probably continue to do the kinds of things that they're doing. They're high consumption lifestyles. Some of them will be busy here, busy there. Some will contribute positively, some not. So that situation is likely to continue. But then the question is, what could they do? And since they have, many of them have very good possibilities to influence people through, they have the very big megaphone, so to speak, and they could actually talk a lot more about the climate crisis. They could talk a lot for example, encourage broad societal conversations about the difficult issues, such as solar radiation modification, or simply to talk about the temperature overshoot that we're going to get, because let's face it, it is going to get warmer, and our leaders are not really talking about it, neither in the government, nor in NGOs, nor in the private sector. So they could encourage such conversations. They could also support massive international programs, like Bill Gates did that for health. There is no reason why billionaires couldn't support major international programs, research programs, for example, to find out what are the true risks and benefits of these new techniques that alter the climate. It's needed, it's necessary to have such activities, and maybe they could do it. They could also support capacities in the developing countries so that it is not all researched and figured out in London and Berlin and New York, but also the world over. And they could support much more substantially, like Bloomberg has provided. Now that the United States is stepping out of the Paris Agreement, Bloomberg decided that he will pay the difference what the US would have paid as a party to that agreement. And then there is one other area, and that's something that is worth discussing perhaps in more detail in this panel as well. Some have suggested that maybe very rich people can do what's called the green finger scenario, that a very rich person could actually start stratospheric aerosol injection, because it's not a very, very expensive thing to do. People say it will cost of the order of $15 to $30 billion annually. Now, that's a lot of money when it comes to my pocket, but many billionaires could actually do that for a few years. So the question arises, will they do it, or should they do it, or can they do it? And I've been looking at some of the analysis of that, and I don't think that they would really be able to do it, because at the end of the day, if governments are not in agreement, they would do something to stop it, even very large potential activities. But they could perhaps work with governments formally, informally, behind the scenes, to actually start doing something. And once you start it, this is where I think you mentioned that in your introduction, the so-called termination shock, that once you start this, it's very difficult to stop quickly. So you have to do something special. And then you could use it to blackmail governments, that if you don't let me do this, then I'll do something else. So there could be some political repercussions there. But this is something that one needs to be ready, because we have already had small private sector doing this. We have a company in the United States called Make Sunsets that started releasing small amounts of aerosols. And that's a very small company, it doesn't have any impact, but it's happening. What if somebody with a few $1 billion start to do that? Are we ready for that? So that's just a few thoughts for reflection. But in summary, what is my answer to the question? Can the hyper-rich save the world's climate? Well, the answer is not really, no. They are part of the problem, but they are also part of the solution, and they can contribute. They can contribute positively, they can also contribute negatively. And I think the challenge that we have is, how can we make them contribute more the positive side, the helpful side, than to contribute on the negative side? And I'll leave it at that. Thank you.
Thank you, Janos. Let me turn it. I'll turn it over now to Benjamin.
Excellent. Thank you very much. I guess I get the pleasure of going last. I'll try to wake everybody up. So it's a pleasure to be here. Thank you, Stephen, for inviting me, and it's good to see you again, Janos. So I wanted to start, I think the reason I was invited is I also manage a very large grant on geoengineering called GENIE. How cool is that? Which literally does stand for Geoengineering and Negative Emissions Pathways in Europe. And as you can see in that lovely green diagram, the cloud with aerosols is meant to signify solar radiation management, but there's another type of geoengineering as well called negative emissions or carbon removal, which also seeks to kind of really do a technical fix of removing emissions out of the air and storing them. And I'm really lucky, there are more than 40 of us on this ERC Synergy grant, and it isn't just myself at Aarhus and Boston University, but also our colleagues at the Potsdam Institute for Climate in Berlin and the International Institute for Applied Systems Analysis, IASA, in Austria. So a very nice Danish, German, Austrian research project. I wanted to kind of only make 3 main points before we get to kind of have a dialogue. The first is to reveal to you some of the technologies that billionaires could realistically deploy this decade. Then I want to talk a little bit about what experts believe might be some of the negative impacts on equity, justice, sustainability, poverty, and so forth. And then lastly, especially relevant this week, what about military conflict, militarization, and weaponization? Could some of these interventions be used for ill to actually create war? And I want to start, you kind of stole my thunder a little bit. Before this seminar, how many of you have heard of the term geoengineering? All right, so about half. Excellent. How many of you have actually seen geoengineering technology or infrastructure? 1 person. All right, I'll take it, Andreas. That's actually a record. Mostly it's 0. Well, I wanted to show you, the first issue, are these technologies really here? Are they only on paper? And there are a surprising number that are actually in society, at least in the form of pilots, demonstrations, lab experiments, and different kind of early stage development. So this is one of them. This is the Carbon Engineering Direct Air Capture Facility in Canada. This actually helps remove CO2 out of the atmosphere, and I think this one is using it to make jet fuel. However, an even better example is this one in Iceland called Climeworks Orca facility. And you can see the kind of size of those trucks there for scale. It's about as big as this room. And it stores 4,000 tons of CO2 per year, which is not that much, but at least it's moving up from very small amounts to thousands of tons. And there are huge efforts now to do gigascale facilities in the United States, especially under previous policy from the Biden-Harris administration with the Inflation Reduction Act. We also have some other kind of wonky things. Janos talked about this as kind of albedo management. But one of the ways that you can manage albedo is to protect ice sheets by covering them with tarps or also sprinkling different things on top of them to help further reflect sunlight. And I had the privilege of going to Greenland to look at where they're trying to do efforts to protect the ice sheet here, which is rapidly melting. In fact, you hear it before you see it. That's how much of ice sheet is being lost. And you can see what they're trying to do is remove dark stones and other materials that absorb more heat off of the glacier so that its melting isn't accelerated. Then we get into some of the other options that Janos showed in his diagram that are surprisingly here. So this is the Great Barrier Reef in eastern Australia. And this is where colleagues are literally already doing marine cloud brightening, fogging, and shading on the Great Barrier Reef. Luckily, this is just water vapor, so they're not creating artificial things like stratospheric aerosol injection might do. But this has already been shown to reduce heat exposure for coral reefs and to improve reef vitality. It's even part of a $100 million Australian dollar project called RAP, the Reef Restoration Adaptation Program, which considered more than 100 interventions to save the reef, and this made it past the 100 to the top 6 that they're doing, along with things like crown of thorns, starfish management, and helping reduce tourism, and doing things like helping reefs recover by doing larvae and genetic crossbreeding. And then we even move to some of the options that might seem fantastic, like SAI, which do exist as well. Janos mentioned Make Sunsets, which is a company that did release aerosols in Mexico. This shows you one of the top labs at Harvard. That's Frank Koich. He works with David Keith. And you can see me there in a coat standing next to a gondola, which would have released aerosols in Sweden as part of the Skopets project, which ended up being terminated because of local opposition from the Sami communities there. But the technology exists, it's in that lab, and that little thing that Frank is pointing at is what they use at Harvard to simulate the stratosphere. So they can simulate the pressure, the atmospheric density, the flow of materials, and so forth. And as Janos mentioned, colleagues at Harvard are saying they could run a regional SAI program for about $20 billion a year. And I looked it up yesterday. Jeff Bezos, Elon Musk have a current valuation of more than $200 billion. So they could do one of these programs and still have 90% of their revenue left to do whatever they want. So these are already definitely within the remit of what some of these hyper-wealthy can do. If you think this is far out, however, I would be remiss if I didn't mention perhaps the most interesting, radical, unconventional option, which goes to outer space. Yes, there are also plans to do geoengineering in an extraterrestrial fashion. You might laugh at these diagrams. The one on the right shows the Lagrange point, L1, which would be where you would put the space shield. That's where the gravitational pull of the sun cancels out that of the Earth, so it's a geostationary point. And if you were to deploy a sun shield there, you could dim sunlight to completely offset temperature increases from climate change. And as the diagram in the left indicates, not only would you have climate protection, you would have a whole bunch of other amazing co-benefits: space trucks, asteroid mining, solar power stations in space, and even, if you see that bottom left, the Alpha Centauri sailing mission where we could start to colonize. We kind of chuckled when we saw these diagrams. They're being seriously considered by Airbus Space and Defense, Boeing, Raytheon, NASA, OHB, and others. We have a study we've published using expert interviews, and here are just 3 quotes about how viable physicists and climate scientists say this is. Look at the quote on the left. All things being equal, as in mitigation, adaptation, I'd prefer us to do space-based measures because they don't involve putting chemicals into our environment. It's universal cooling, it can be tweaked, it's controllable, and it's easily monitorable. Or in the upper right, it's just a plan B, airbag solution. It's not meant to stay there after 20 years. We'll be able to remove it then because we will have solved climate change. Anyone here from the Netherlands? It's just like the Dutch Delta works in space, right? The Dutch building of dikes and dams, right, off their coast. That's the analog. We've done it on Earth. Now we just have to take it maybe a little further abroad, right, to preserve our way of life and protect our land. So obviously these options are more deployable and perhaps closer to potential deployment than we may think. There are colleagues of ours, Frank Bierman has even led signatories for a non-use agreement that believe we need to urgently have a moratorium on deployment so that we don't see some of these options recklessly proposed. And what we've also done in our work is looked at some of the potential justice impacts. And what's interesting, based on expert interviews as well, they don't just occur where the technology is used, which is right there in the gray. There's also a kind of hidden whole system behind these options. Where are the metals, minerals, and materials that are used to make them? Whether it's basalt for enhanced weathering or fertilizer, or who actually makes and owns the patents for the aerosols that are being injected into the stratosphere? Who works on them? Is it in the global south or the global north? What are impacts on poverty and agriculture? In Africa? What about all of the input from solar photovoltaics, which now becomes less because we're having less sunlight affect the earth? What about land grabbing and the dispossession of indigenous groups? Because you would need large amounts of land to do many of these programs. Or what about aerosol injection over tribal communities? We've already seen the Sami in Sweden rigorously oppose even an experiment. And after Make Sunsets did their pilot in Mexico, geoengineering was outlawed in Mexico. And then lastly, what about disposal and waste? What about the waste streams that are created? What about liability for accidents? What about attribution? One of the other things that we did in our expert interviews is we asked people, oh, I forgot. It also isn't just about scales of justice. It's about types of justice. And it's about far more than just distributive justice, which is costs and benefits. It's also about recognition justice. What are the vulnerable groups that will be most harmed? It's also about participation and due process. Who makes policy? Is it just technocrats? Is it just the UN? What about responsibility? What about this great term mitigation deterrence or moral hazard? If we think we can rely on the sun shield or aerosol injection, why bother with mitigation? The IEA is telling us we have to invest $100 trillion by mid-century in mitigation and net zero infrastructure alone. If the space shield is $1 trillion, that's 1/99th the cost of our mitigation efforts. And then what about capabilities? Who has the technological know-how, the resources, the intellectual property? Is it elites? Is it Virgin? Is it Boeing? Is it Raytheon? Is it the US Department of Defense? Or are there more democratic ways of doing SAI? Is it Greta? And is it social movements and cooperatives and community groups? The last thing we did in our expert interviews is we were really concerned with the ability for these options to be used as weapons or to accelerate military capabilities or militarization. And we actually found 4 different ways that geoengineering could create geopolitical tension or conflict. The first one is as negotiating tools. Now, we already got mention of the green finger. For those of you that don't know, that's a kind of analog to James Bond and Goldfinger, who was going to take over Fort Knox and actually use it to drive up, I think, prices of currency around the world. Well, a green finger is the same thing. Not only is it about use, it's about the threatening of the use by blackmail, also Austin Powers, to actually receive, say, a ransom. However, there are other ways in which geoengineering could be a geopolitical negotiating tool. You could create new cartels and clubs. People talked about perhaps a green OPEC or an aerospace OPEC that control bioenergy supply chains or aerospace technology, satellites, high-altitude aircraft, and monitoring systems. Or it could be concessions that people threaten to use geoengineering in exchange for better immigration policy or trade policy or for other non-environmental related things like, say, conflict in Ukraine or Iran and Israel. But a negotiating tool is just one of the ways in which these options can intersect with weaponization. The second is enhancing military capacity, whether you deploy them perhaps around military infrastructure, or maybe now you deploy the military to protect the resources you need to make them. Or it could also be that you need them to deter attacks on existing carbon infrastructure, say carbon reservoirs, right? If there were carbon reservoirs in Iran right now, they could have been threatened to be destroyed by Israeli or US forces. There's even one expert we interviewed who talked about how they think while the US military had its 5th wing of the Space Force, the 6th wing will be the environmental force, where the military now goes around and enforces environmental statutes, especially if we come to depend upon negative emissions technologies that have immense liability. These options could also be targeted in conflict. You could physically attack them during military campaigns. You could attack their software or SCADA systems, or you could just have them be interrupted by accident. And this, you may remember in Kosovo, the United States bombed the Chinese embassy by mistake. If we can't even properly target infrastructure during normal conflicts, imagine misattribution and miscalculation in things like geoengineering infrastructure or carbon networks. And then lastly, they could cause conflict. Whether India deploys against China, North Korea against South Korea, or they create insecurities. Let's say that India deploys SAI and has a much greater harvest and much more stability. China does not. That creates asymmetries in climate protection that then motivates China to correct that asymmetry by attacking India. What about miscalculation? What if India never actually did anything but the Chinese say they did and use it as a proxy? And lastly, what about counter-geoengineering and arms races, where you have proxy geoengineering research, the same way that the United States had research on chemical weapons and smallpox, not for use, but to counter use in case it occurred. All of which still demands that you increase the capabilities. So here we have no less than 15 different ways that geoengineering could really complicate climate statecraft and geopolitics. Now, lastly, this came up over lunch with Stephen. I wanted to just raise two other interesting findings from the Genie project. One, we ran in a totally separate exercise 44 focus groups across 22 countries and asked them to envision a geoengineering future in 2030. We had 22 focus groups with about 350 respondents. What this shows you here are the 5 most common imagined futures. And these are surprisingly collective. These were completely unprompted, and it wasn't done in a group, as in they were at the focus group, but they went individually to write down their future. And amazingly, in more than 60% of the focus groups, the global green belt was prevalent, in which we see massive afforestation and reforestation efforts, some of which are done by billionaires. Jeff Bezos, Elon Musk were named. We also see perhaps crop failure and cancer from stratospheric aerosol injection. Again, billionaires were named, as well as Bill Gates, as the architects of deployment. And lastly, we see the interplanetary sun shield, where we do go to space. These visions of crop failure and cancer and the sun shield were still prevalent in 25% of the focus group. So this gives you a sense, like, when the ordinary public imagines a near-term future of where we've done geoengineering, the green finger scenario is very prevalent. Probably because the technology is so speculative, this helps them ground it by having it attached to a familiar actor. And then lastly, coupled with the survey, with the focus groups, we ran a survey in 30 countries with more than 30,000 respondents in 17 languages. And one of the questions we asked is how people feel about geoengineering. And this helps show, unfortunately, there's no Hungary in the sample, but we have Austria and Germany, so we're getting kind of close by. And this helps show you all of the emotions. The green is where the emotions are positively affiliated, and the purple is where they are not affiliated. So look how much hope Indonesia, Nigeria, India, Saudi Arabia have in geoengineering. Look how afraid Brazil is. Look how angry Italy, Spain, and Greece are, and look how sad they are. And it really helps reveal the whole spectrum of fear and anger and hope that the public has. And counterintuitively, both positive and negative effect have greater salience for geoengineering. If you are fearful, it's positively related to your support for SRM because you're afraid the risks of climate change are seen as worse than the risks of deployment. And if you're hopeful, well then of course you have confidence that scientists can do it right and we can create governance. So it's kind of a weird, either way, emotions are pushing people to more rapidly embrace and positively favor these geoengineering options, including SRM. And so is worry, and so is sadness. And with that, I'll happily open it up to you, Stephen. Thank you.
So I'm going to first give an opportunity for the two panelists to respond to each other, and then we'll open it up for questions and answers after that. So we'll start. Janos, you press that.
Okay. I was struck by the last part of your presentation about the military uses and that lend themselves to questions of security and things like that. And what strikes me is that even if you cannot measure the climate impact on one particular region or country, it's the perception that matters. And I wanted to find out if in your study you looked at that particular issue, the question of perception.
No.
Okay. So there's the next project, right?
I mean, we did 125 expert interviews, and the question wasn't about weaponization, it was what are the risks of deployment? And so it was just by chance that so many experts talked about weapons in the military, more than 50, that we were able to write that paper. And for symmetry, I should say the first half of the paper presents all those risks that you saw, but the second half actually deflates the threat and says they won't be militarized because they're really poor weapons. They have poor targeting, poor attribution, and you can get much more bang for your buck with, say, smart bombs or computer viruses. And so I like that, you know, as good social science work does, we're not saying it is securitizable. There is a debate, and there were a fair number of experts who also talked really realistically about how they won't be really weapons at all. So I like that the experts seem split on whether they're for or against.
Okay. And I have one more question. It's also in the end the bit about the emotions. So is that because most people, it seems to me that most people still don't fully understand what these technologies are. And is it therefore that they more rely on emotions to evaluate the techniques? And do you expect that with more information, more knowledge that might be available through you know, society-wide conversations or whatever they may be, that will change the picture on the emotions?
Potentially. On the one hand, levels of public familiarity with these options are much lower than, say, nuclear power or solar photovoltaics. But I think one of the things that we often do in academia is we greatly overestimate the public's literacy and knowledge of even ordinary energy options. In totally different projects, we've been working with communities, especially people of color in the United States, about solar PV. And we have another project in the UK in its heartlands talking about hydrogen and CCS. And there, public knowledge is just as bad. People literally think solar photovoltaics are for mind control or weather control. Here's another one, Janos. Smart meters measure intelligence. And people associate hydrogen with the Hindenburg blimp and carbon capture with diamonds. Right? So, like, I'm not sure that the public is having much real informed, say, the average public, not the educated public. But the average public, I think, may not know much about any of these options. So it isn't just geoengineering. So in that regard, emotions might be a good proxy for how they feel about technology, whether it's solar PV or SRM.
And maybe just one more. I've always been troubled by this, that mixing carbon removal techniques and solar radiation modification techniques is complicated because they are so different. The techniques are different, the governance challenges are different, the reasons why you do them are different. They're all related to climate, of course. But do you think that was helpful for your project to look at both of those together?
I sure hope so. No, absolutely. We were really concerned that too much work looked at only one or the other, only solar radiation modification or carbon removal. And in reality, they can be used as portfolios. We've already seen some of the integrated assessment models like DICE run simulations that include SRM and CDR. And it kind of mirrors the policymaking dilemma. If we can't mitigate and we can't adapt, then policymakers are considering the full range of these options. And SRM can affect CDR, and CDR can affect SRM. So I think that's one of the strengths of looking at them together, because they could realistically be used together.
Okay, but then don't you have to then look at all the climate actions together, including mitigation, emission reductions, carbon removal, adaptation, resilience, cooling, all of that together? Then I am okay with that.
Yes, and the next round of the survey is doing just that, Janos. So okay. Excellent.
Excellent.
Thanks so much for that dialogue. I'd like to now open it up to the floor. I will have a question on international governance a little bit later, but I think because of the time, it'd be good to hear from the audience, to see what questions you may have. I see some people, I think, chomping at the bit. So anyone would like to have the floor? I see this gentleman here to start. Maybe we'll take a few. There's one person in the back. Anyone else?
Thank you.
And over here. Okay.
I'm George Sabo. Just to introduce myself again. All these topics have been, I think, quite long ago on the agenda. When I was working in the OECD, we had business groups, intergovernmental organizations, all presenting their views on similar topics. And I think, although we did advance globally on these issues, but the pace of change is lagging behind the pace of change of the climate change. So my question to both of you would be, instead of thinking about what the hyper-rich can do in order to advance these topics, what could governments do in order to tax the hyper-rich comfortably enough to finance the public side of these problems? Because I think that this would be, I think, the depth of governments via the public whose good they are supposed to serve.
Thank you. Let's take a couple more. So the gentleman all the way in the back there is next.
Thank you very much, Max Steuer, Communist University, fascinating talks. I have one question and one sort of meta question. So the question is on whether the elite's perceptions of emergency change the likelihood of them supporting these pro-climate projects, whether you have any data on that. And the second one, because you've mentioned so much valuable social science, empirical research, but also insights from theories of justice. I wonder how important cooperation between disciplines is from your perspective for understanding these phenomena. And it's a meta question, I would say, also because just this week there is another attempt apparently of discontinuing this interdisciplinary collaboration in Hungary at the level of the Academy of Sciences, disconnecting 4 social science humanities institutes from the natural sciences and somehow saying that they are not directly relevant for solving the problems of the society. So I wonder to what extent this is essential for finding these kind of new solutions, this interjection of humanities into the climate, natural science, engineering research. Thank you.
Okay. Thank you. And we can go with József on the left here.
Thank you. József Slezák, Central European University. So I didn't know much about geoengineering, and thank you for the introduction. I believe the geoengineering might play a role in solving the climate crisis and the polycrisis. At the same time, I was wondering during your presentation, so in the last about 15 years or more, I have been following the debate whether we need more technology or we need to invest into people and societies as a whole, like social capital, knowledge, and etc., towards sustainability. And what I have seen so far regarding technology, except some fewer success cases, were big failures. And I remember also having been here in this same room a couple of years ago at a seminar by the European Environment Agency on the precautionary principle, where they presented several cases, what they have studied, how the risk of environmental technologies and environmental solutions have been underestimated, and then society paid the price. So they have vast amount of publications about it. The European Environment Agency is still downloadable from their website, I believe. And then very many other examples could be mentioned. For example, also the companies who promised like CO2 sequestration, and they gathered billions of dollars from companies promising climate neutralization, until someone, a group of researchers have found out that their projects in Africa make more harm than good. And this company, by the way, is seated in Switzerland and called My Climate, so anyone can check this based on internet sources. So coming back to the topic of the panel today, what the hyper-rich could do. By the way, I'm not familiar at the statistical level of this definition, hyper-rich, what exactly it means. But I know that the wealthy cause the 20% of society worldwide, the wealthiest 20% cause about 80% of the pollution, including also CO2 emissions and all the emissions related to climate change. So one of the speakers mentioned that, well, they won't change their lifestyle, but maybe they could finance project. I think actually we do need to talk about lifestyles. What is that we want to achieve eventually with these projects, that we remain the same society with the same lifestyles? You mentioned Tesla. Most Tesla cars are driven, used by one single person. Compare it to public transport. You mentioned Tesla as a wonderful success story. For me, it's not a success story. I digged into this and I presented to my students how Tesla and other electric cars companies take advantage of people in Ghana from where they source their the necessary materials, amongst them cobalt from the accumulator. So all in all, I think we need to be precautious. It's easy to present technologies as promising in short presentations like this, but I would call for civil control and civic control over all these technologies, and any ideas about geoengineering. And maybe this could be a question to you, particularly to Professor Pasztor, whether you have some experience with negotiating and debating the ideas with the civil society, and what your experiences are in this regard. Thank you.
Okay, thank you very much, Josef. I think that was about 12 or 15 questions in your intervention, so we're not going to expect you to get all your answers right now, but I think you can do a good job trying. So I'll give it first to you, Janos, to respond to these first interventions.
All right, let's start. So first of all, I think there will be a session on taxing the hyper-rich, no? So let's hear what the other panel says about that. But I do agree that, personally, that the most important is to make sure that societies tax appropriately. And we've seen in the history that taxing rich people doesn't necessarily reduce progress and growth and all of those good things of capitalist societies, right? So let's start with that. I think the issue of emergency was brought up, and whose emergency it is. I think that's important. Sometimes we see people from rich, wealthy countries talk about what the poor needs in another part of the world. We've seen that before quite a lot. But what we also see increasingly is now capacity in the global south evolving, where they make their assessments and they say that they have an emergency, and that's a very different story. So that's why it's so important to make sure that we have broad societal conversations, not just in particular countries, but between different regions, so that the information flows and the experience of people with climate change gets expressed and heard and then followed up as much as possible. Now, you raised quite a few issues, and I think maybe I start with the fact that you're absolutely right about the electric cars. What I tried to say in my brief statement earlier is that, of course, running an electric car versus a petroleum-based car is much better from an environmental perspective. And in that sense, what Elon Musk has done is really push the envelope, and that we have to recognize that. But electric cars does not solve the climate crisis. Absolutely not. And it's something much more complicated. And that's why I said that we've done the low-hanging fruit, because that's easy to make electric cars. What is much more difficult is to change the industry and change our lifestyles. From private traffic to public transport, from less meat eating, food systems, all of those things. So and that's the important part of for me, the climate crisis, is that we have barely touched on the difficult part of how to address these issues. Now, precautionary principle, very important, but precautionary principle has two components here. One is that the climate crisis is resulting in major negative impacts on the environment, on people, and on the economies. And so we need to have that precaution to vis-a-vis that. But we also need to be to make sure that we look at that also for the new technologies, and that is why it's important to do what is called a risk analysis. We can't just simply say that all these new techniques will come with all kinds of risks. Yes, they will come. Everything has risks, everything. But the question is, doing it versus not doing it, which one will give a better world or a less worse world? Because right now what's happening is that the climate crisis is really providing major impacts, negative impacts worldwide. And then the question that society has to figure out is whether the application of some of these new techniques, will that make the world a little bit better or a little bit worse? And we don't know that yet. There are some beginnings of some studies that begin to look at that. So the precaution has to be vis-a-vis the technology, but also vis-a-vis what is actually happening even without the technology itself. And I think I'll leave the rest to...
Thank you, Janos. The risk part is really cool. And you're not mishearing that. It does set off your Microsoft Word because it's like risk. But it was initially meant to underscore the risk of climate change versus the risk of geoengineering. You know, you don't eliminate risk, you merely substitute it. And we've done follow-up work in Genie that finds that the risk dimensions also multiply because solar radiation management pathways have risk trade-offs with each other. They have risk trade-offs with carbon removal. They have risk trade-offs with mitigation and adaptation, and all of the 18 Sustainable Development Goals. So it's like 6-dimensional chess trying to calculate that cornucopia of risks. And unfortunately, you can now have even advocates of SRM point to risk trade-offs because risks are everywhere. So I don't think these interventions eliminate risk, they just transfer it in space and time. The point that was made about the humanities and the social sciences is an excellent one. It's largely how we won our ERC grant because it was qualitative social science meets quantitative social science meets evidence synthesis meets integrated assessment modeling. And we had done a little content analysis in our grant proposal that found that at the time we did it in 2020, 95% of research was technical and economic. So what about ethics? What about politics? What about governance? Sociology, social perceptions, business models, you name it, policy mixes. And so I think that really we identified a key gap. And let me also say, I had the privilege of co-chairing a recent scientific task force last year on SRM. It's one of these pan-European national academies groups called SAPEA, Science Advice for Policy by European Academics. Did I get it right? Sounds right. And we put together a task force to do a report on SRM. 10 technical scientists, 10 social scientists. Janos was at one of our seminars. And let me say the report's published. It's got about 1,000 references. And I was blown away. The social science half of the report is longer than the technical half. So there's more academic evidence now about ethics, law, justice, mitigation deterrence, governance, politics, than there is on the ecological impacts or the modeling or the science. So I think what better proof that we absolutely need the social sciences, they already are central, and the humanities, especially if you count law, jurisprudence, philosophy, and ethics as humanities. There are hundreds of studies now on this. And so yes, I think it's, don't create this techno-economic bias of just running a model. And lastly, in terms of what governments can do, I know we're going to talk about taxation. We did research at Sussex University 3 years ago about provocative, non-discussed government interventions. We all know, most of us, about feed-in tariffs and portfolio standards and tax credits. And there's like 90 different policy mechanisms governments can use, but we're not making progress. And so in this paper, in energy policy, we identified 3 very unconventional tools, none of which have been done yet, that would greatly accelerate climate action. Number one was a maximum wage. We have a minimum wage, we have a maximum wage, and a cap on equity. Number two, my colleague Pete Newell has talked about a non-fossil fuel obligation treaty, similar to the NPT, but now done for phase out of fossil fuels. And number three, a carbon currency or currency that is pegged to your carbon performance. So if you don't reduce emissions, your currency collapses, right? Three very interesting tools no one is talking about that would certainly change at least our performance on climate change.
Okay, so I know we have a few more questions. Can I see how many people, because we're going to manage the time a little bit. I see Andreas. Other people would like to ask some questions. Okay, there's another person there, so two. And then I'm going to ask a couple of questions as well. So let's hear from Andreas, and then from you back there, and then I'll ask my questions. And another person in the back. Okay, Andreas, please.
Yeah, there's that book by, I think it's Douglas Rushkoff, The Survival of the Richest, where he analyzes what he calls the mindset, kind of the mindset of hyper-rich tech bros who basically have a very kind of see themselves like philosopher kings and have technocratic solutions to everything. And the more radical, the better, the more scalable, revolutionary, the better. So all these, or probably not all, but many of these geoengineering technologies seem to be super fitting to that mindset. Someone who thinks we really need to go do a big jump, people are the problem, we can't count with the people, we have to do it ourselves. But as it seems, there's kind of one big obvious hole. They want to do things that are profitable, that are marketable. And geoengineering kind of isn't, right? So that might be the huge barrier for the hyper-rich getting into that field, except they have some,
Yes, I can directly relate to that. Patrick Zach, the University of Bremen. We know that, of course, the hyper-rich contribute disproportionately to carbon emissions, and but we also know that it's not only their consumption, but it's then mostly also their investments, what's doing sort of the harm and what's problematic about sort of the carbon effects of their wealth. So I'm wondering if you're not sort of talking about only individualistically about changing their consumption behavior or their lifestyle, but thinking about sort of collective regulations or institutional provisions that would sort of redirect where they invest their money, whether that might not be a more amenable strategy to sort of get the rich also on board in terms of doing something good for the climate, without hoping that they might find some profitable project they can jump onto. The second question is that sort of what also strikes me about these technological solutions is their solutionist optimism in a way, and how can we be sure that this isn't just, you know, a way to circumvent the dilemmas and collective action problems that on the social science side of the climate crisis now prevent effective solutions being implemented?
Indrajit Parmar from City University of London. I just had a question for both speakers, but mainly for Benjamin. You said about the deployment of social scientific thinking and experts in your projects, and I just wondered, and I was interested in the kind of geopolitical possibilities and consequences of some of the geoengineering fixes that you were talking about. And I just wonder whether or not your groups had considered how technical solutions are also very heavily political, because it depends on who has the resources to be able to deploy them in any way, you know, that matters. So to what extent did any of the considerations that you had in mind in your reports, for example, take into account that there are vast inequalities across the globe between the power of states, which will then impact on what is deployed where? And then, because we've already seen domestic inequalities, you've talked about the fact that when it comes to any kind of management of climate change or anything like that, then very often the worst facilities, the dumping and so on, takes place among communities which are the poorest and most vulnerable. That is to say, technology and power are kind of locked in a particular kind of context. I just wondered to what extent that sort of more critical perspective had been entertained or considered in your research reports, which sound really, really interesting.
Okay, one other person has eagerly asked for the floor, so I'm going to give the floor.
I have a very small addition to that question. Giovanni Occhiali from IDS, so very close to Sussex. How important would it be in connection to the politics of it to make sure that the average citizen understands what we're talking about here, right? Like, you know, the three policy solution you mentioned that no one is talking about, they're all politically unfeasible today, right? They will not become politically feasible if there isn't a demand, at least in democracy. People don't understand solar photovoltaic panel. How can we explain a currency pegged to carbon emission and make them understand that that might be in their interest? I mean, what is our role as people in this room to make that happen?
Okay, before I pass it to you for this last group of questions, I'm going to present two small additions, which if we run out of time, don't worry about it, but if you have a chance to cover these issues as well. The first is that, you know, we talked a little bit about that you both have worked on the issues of the attitudes and the experiences of children and youth in this kind of, you may call it a battleground. And Benjamin, you've done studies on youth awareness. Janos, you have funded the SRM Youth Watch. You know, what are your sort of general feeling about the attitudes of the younger generation? Particularly, we can sit up here and say all kinds of things, but it will really depend on them, you know, how things move forward. The other is that in the area of international governance over SRM, the last time that this was discussed in the context of the UN Environment Assembly, there were essentially three blocks which could not agree, and in the end there was no resolution of the issue. I don't know whether this is going to come up again this year in the United Nations Environment Assembly, but the three blocks, essentially you had a group, an African group that was looking for a total moratorium. You had an EU-led group that was looking at having a transparency register of activities and experiments related to SRM, and then you had a kind of US-led group which was kind of business as usual, with the governance being more or less in the hands of the World Climate Research Program, which it's, you know, has been up to now. Questions about that. So just maybe if you do have a chance to say, you know, what would be really the right way to deal with these kinds of alternatives of how the international community can approach the governance issue of SRM. And that's, I think that'll be it for the time that we have, but take your time. I think we can, you know, we started a couple of minutes late. We can end a couple of minutes late. So please respond to all these questions that have been asked.
No, so I'm going to go first because I didn't write anything down. So I'm going to do this before I forget. I'll let Janos talk about kind of negotiations internationally, Stephen. The youth one, just to say, in our focus groups and survey, we find that youth are much more positively associated and predetermined to support both carbon removal and SRM, and as you go up in age, support declines. To the point about kind of politics and literacy, there are some paradoxes there, and I can find you later. We did a fascinating study of energy literacy in Denmark, where we were like, they're going to kill it. They pay so much for energy there. They must be really super literate, and we found they're almost as illiterate as the Americans. And the more education you have, the less literate you are about energy and climate, but the more confident you are that you're right. And so in that regard, we were kind of like, the Danish energy transition works so well because the public is ignorant and let knowledgeable, benevolent experts decide. So it really upends our notion of energy democracy and has some really interesting implications. Maybe not that interesting. I mean, I don't necessarily want MAGA Americans making energy policy right now. They call fossil fuels molecules of freedom. You know, so there is this real tension between leading the public and listening to the public. In terms of other social science work, yes, my colleague Sean Lowe, who was one of my postdocs, did a great piece in Global Environmental Change looking at hard and soft paths for geoengineering. This is kind of going back to Amory Lovins, who talked about energy system organization that's democratic, bottom-up, grassroots, and modular versus top-down, centralized, corporate, and anti-democratic. And we find for these options, you can do it both ways. You can have top-down monocultures of infrastructure owned by BP and ExxonMobil and Monsanto, or you can have social activists, cooperatives, community groups, hospitals, banks, and all of that do it from the ground up. So it's kind of like whether we make the pathway hard or soft will depend now on what we do. And we have a separate paper with Holly Buck on the political ecology of geoengineering, which is all about power relations, and socio-ecological vulnerability. It's under review. The final two questions kind of about profitability and how we might incentivize or not incentivize. I can just say two quick things. One of the things we did in Genie is an expert elicitation, where we asked experts who have patented the technology or who have been highly published, what would it take to make the options profitable? And the answers were really interesting. SRM is never. SRM will never be profitable. It'll only work by governments because it's a public goods problem. And then for things like negative emissions, they're anticipating, our experts, you need a carbon price of $200 to $500 per ton for things like CCS, and up to $1,000 per ton for direct air capture by 2050. So that also may imply why these options won't happen unless you will see political and market systems align to give the proper incentives. And the final thing I wanted to say is when we talked about risks and benefits, there's a colleague of ours, Alan Robach, who's very critical of geoengineering. And he came up with a great term that I like. He said, the problem with deployment is not the slippery slope, where someone deploys and someone else deploys and then it's runaway deployment. It's the sticky slope of the first person to deploy will see such backlash that it may stop deployment overall. And I at least like that tension, that if we were to see one program at scale and it were to go wrong, that might actually tilt the scales to have a moratorium. And that may also be why many billionaires aren't doing it, because they don't know enough yet about the science and the technology's capabilities.
Okay. I'd like to go first to Andres' question. It's true that there is not much money to be made in stratospheric aerosol injection. There will be a company who makes the appropriate aeroplane, and there will be some money there and so on. But basically, it's a cheap, relatively cheap thing to do. $20 billion, $30 billion globally, annually. This is not exciting for the private sector. But I don't think that the Goldfinger, the hyper-rich person getting engaged in something is only about making money. Sometimes it is, but sometimes it's simply the power to be able to control. And so I could imagine, let's not mention names, but I could imagine individuals who say, okay, we're going to fix this because I can do it. Whether they make money on it or not is another story. So. In fact, that's part of the problem, in a sense, of stratospheric aerosol injection. Is so cheap, relatively speaking, that it might encourage countries to look more seriously into that option because it is relatively low cost. I think that maybe I'll start at the back end, the last questions, and then maybe go up further. The youth, I think that's, you have the data, but we've also experienced the same in our work. The youth, it's their future. They're the ones who are going to live the rest of this century, and they will live to a world which is either 2 or 3 or maybe even more degrees above historical average. So they are really concerned, and they ask questions, and they, in my experience, I don't think I've seen that the youth are suddenly pro-solar radiation modification or something like that. But they are prepared to look at it more consistently than their older counterparts. And I think that makes a lot of sense from that perspective. In terms of the negotiations, Stephen, I think this is hard because I think we all agree, and it has been discussed here and elsewhere, that the governance issues are the more difficult ones when it comes to these technologies. It's not the science, it's not the building the aeroplanes, not spraying the stuff out there. It's the governance. Who decides on what basis, whose information, who has an input, who doesn't have an input. And these are difficult, and the challenge is that I think the world is still talking a lot about governance as a single thing, when in fact governance has many different components. There is governance, more formal governance in relation to research. There is governance about preparing for a decision. There is governance to do the decision. And then there is governance to implement the decision. And they're completely different, and they need different institutions. And I think the problem we've seen in UNEA, the UN Environment Assembly, which not for the first time, but for the second time, there was an attempted resolution on this topic, and it failed. It failed to bring consensus because people still mix these things, and it's not clear what belongs to the UN Environment Assembly, what belongs to the UN General Assembly, and what belongs to the UN Framework Convention on Climate Change. And when I was still the executive director of this C2G initiative, we did lots of conversation with government leaders. And there is simply not consensus on where to take this issue. Some feel it must go to the UNFCCC, the UN Framework Convention on Climate Change. The others say, oh no, forget about all this stuff, we have to go to the General Assembly right away. Brazil is one of those, and so on. So I think what is needed here, perhaps as a next step, not to try for yet another resolution that may fail, but to have more conversation at various levels, by governments, but also with the representatives of non-state actors, to try to understand better what are the different bits and pieces of governance that are needed, and how they can then be located in UN Environment Assembly and others. I continue to believe that the UN Environment Assembly has a very important role to play. After all, their most important mandate is to bring to the attention of governments emerging issues that have an impact on the environment. Well, this is clearly one of those. So that's there, but that doesn't mean that all the governance issues relating to solar radiation modification, or for that matter, the whole family of climate altering techniques fits there as well. So whether it will come up, I don't think it will come up this year, frankly, because this year the focus of the Environment Assembly is the plastics negotiation, and I suspect that there is just not enough bandwidth for that now. But it will surely come up again. And one more issue, and that is a sort of a good example of what I said before. The United States was not too keen on having this discussion in the UN Environment Assembly because they want to keep all these discussions at the international level at the scientific level. They don't want to go into the policy discussions because they don't feel comfortable with that. So it's okay to have the World Meteorological Organization have a research program on the atmosphere. They can do it there. They're sort of okay with the IPCC doing these things, but they're not okay with the UN Environment Assembly doing it, or for that matter, the General Assembly of the United Nations. So that will still require quite a bit of work and quite a bit of conversation between member states to see what is the best way forward. Okay, I think I leave it at that.
So I think this brings our panel to a close. We've gone a little bit over. I'm apologizing to the next part of the agenda. I want to thank you very much, Janos and Benjamin, first of all, and also our participants in the audience for some really excellent questions and interventions. You know, we are at DI, we are defending democracy, or the idea of democracy. But I think, you know, one of the things we always have to ask is what's the proper role for democracy in these issues? I think this discussion we've had today really shows that that's a very complex problem. And I think we're fairly confident that there's a role for democratic governance in SRM at some point. And I don't think we got very far in determining what that role exactly is today. But I think we have a lot more to discuss and a lot further to go. So again, thank you once again. And I will now return the floor back to the organizers. Thanks so much.